You type a sentence: an astronaut riding a horse on Mars. Hit generate. 30 seconds later, a photorealistic image appears. That never existed until this moment. Perfect lighting, accurate details. Impossible made real. But here's what just happened that almost nobody understands: the AI didn't draw this. It didn't paint it pixel by pixel. It didn't sketch, render, or composite. It didn't even know what an astronaut, a horse, or Mars looks like. What actually happened was far stranger. The AI started with pure noise, television static, and through billions of mathematical calculations, slowly sculpted that chaos into your exact vision. No artist. No brushes. No understanding. Just math transforming randomness into reality. In the next few minutes, I'll show you exactly how AI image generators like Midjourney, DALL-E, Stable Diffusion, Adobe Firefly, and Leonardo AI actually work. The real process behind the technology that's changing art, design, and creativity forever. Let's start with what seems impossible. You give AI words, just text, and it creates images. Visual representations of things that never existed. How does language become pixels? The answer required 3 revolutionary breakthroughs that converged in the last 5 years. First, teaching AI to understand what words mean visually. Second, teaching AI to generate images by reversing destruction. Third, combining these capabilities into a unified system. Every major AI image generator, from Midjourney's artistic mastery to Leonardo AI. Leonardo's commercial safety, builds on these same 3 foundations. The first problem: computers don't know what astronaut means. It's just a sequence of characters. So how do you teach a machine that astronaut connects to spacesuits, helmets, NASA, and zero gravity? The breakthrough is called CLIP, Contrastive Language Image Pre-training. Developed by OpenAI in 2021, CLIP revolutionized how AI understands visual language. CLIP was trained on 400 million image text pairs scraped from the internet. Photos with captions. Illustrations with descriptions. Art with titles. The training process was elegantly simple. Given an image and 100 possible captions, which one matches? Given a caption and 100 possible images, which one fits? Through billions of these matching exercises, CLIP learned to map language and images into the same mathematical space. Words and visuals became coordinates in a shared universe of meaning. When you type astronaut, CLIP doesn't see letters. It generates a mathematical vector, a point in high-dimensional space, that's mathematically close to space, helmet, human, NASA, and distant from ocean, forest, or kitchen. Horse maps near four-legged, mammal, mane, galloping. Mars connects to red planet, rocky, barren, alien landscape. CLIP transformed language into navigational coordinates pointing toward visual concepts. This is why DALL-E 3 excels at understanding complex prompts. It uses GPT-4 to expand your simple request into a detailed description, then CLIP converts that into precise mathematical guidance. But CLIP only understands images. It cannot create them. For that, we needed a completely different breakthrough. Imagine you have a photograph. Now add a tiny amount of random noise to it. Like TV static. Then add more noise. Then more. After 1,000 steps, the original image is completely destroyed. Just pure randomness. Complete chaos. Now here's the revolutionary question. Can you reverse this process? Can you start with pure noise and systematically remove it until a coherent image emerges? This is the core insight behind diffusion models, the technology powering every major AI image generator today. Researchers trained neural networks on millions of images, teaching them two complementary skills: how to progressively add noise until an image becomes static, and critically, how to predict and remove that noise step by step. Think of a sculptor. You don't start with a finished statue. You start with a block of marble and chip away everything that isn't your vision. Diffusion models start with noise and chip away everything that isn't your image. Stable Diffusion pioneered making this technology open source and efficient enough to run on consumer hardware. Midjourney refined it for maximum artistic quality. Adobe Firefly optimized it for commercial safety using only licensed training data. But here's the crucial point: at this stage, the AI still doesn't know what image to create. It's only learned the general skill of transforming noise into coherent visuals. The magic happens when you combine diffusion with text guidance. You type your prompt: an astronaut riding a horse on Mars. Clip instantly converts this into mathematical coordinates, a specific point in concept space representing your vision. The diffusion model initializes with pure random noise. Television static. Complete chaos. Now comes the iterative refinement. Over thousands of steps, the model predicts what noise to remove while Clip steers the process toward your text description. At each step, the system asks, is this evolving image getting mathematically closer to astronaut, horse, and Mars? Or drifting away? If closer, continue this trajectory. If drifting, course correct. Step 1. Pure static. Zero coherence. Step 300. Vague shapes emerging. Perhaps a horizon. Possibly a figure. Step 600. Forms becoming clearer. Something four-legged. Something humanoid. Reddish terrain. Step 1000. Recognizable elements. A suited figure. An animal. Rocky landscape. Step 1500. Details sharpening. Helmet reflection. Horse muscles. Martian geology. Step 2000. Final refinement. Lighting effects, shadows. Surface textures. The result: a photorealistic astronaut riding a horse on Mars. Created entirely from mathematics and noise, guided only by language. This process is fundamentally identical whether you're using DALL-E 3, Midjourney, Leonardo AI, or Stable Diffusion. The differences lie in optimization, training data, and specialized tuning. Let's examine how the 5 leading platforms differ in their implementation. DALL-E 3, integrated into ChatGPT, leverages GPT-4 for prompt engineering. When you type astronaut on Mars, GPT-4 expands it, a photorealistic image of an astronaut in a white NASA EVA suit with gold-tinted visor, riding a muscular brown horse with flowing black mane, on the red rocky surface of Mars with pink sky and distant mountains, cinematic lighting, ultra-detailed. This expanded description provides far more precise guidance to the diffusion process. DALL-E 3 excels at following complex, multi-element instructions and rendering readable text within images, capabilities other systems still struggle with. However, DALL-E is heavily filtered for safety. It refuses certain content, modifies prompts to ensure diversity, and sanitizes outputs. It's the most controlled system. This is why even simple prompts yield stunning results. Users rate outputs, and popular aesthetic preferences influence model updates. The AI learns not just what's accurate, but what humans find beautiful. This openness sparked massive innovation. The community created thousands of specialized models, fine-tuned versions for anime, architectural visualization, photorealistic portraits, specific artistic styles. Extensions like ControlNet allowed precise composition control using edge detection, depth maps, or pose guidance. Stable Diffusion proved that cutting-edge AI image generation doesn't require corporate infrastructure. A capable gaming PC is sufficient. But openness comes with trade-offs. The base model lacks the polish of commercial alternatives, and without content filtering, it can generate problematic outputs. The power is there, but responsibility falls entirely on the user. Adobe Firefly addresses a critical concern that haunts the entire AI art industry: copyright and commercial safety. Most AI image generators trained on billions of internet images scraped without permission or compensation. Firefly was trained exclusively on Adobe stock images, openly licensed content, and public domain works. Every image in its training set was legally authorized. The trade-off is creative limitation. Here's something crucial most people miss: these systems don't understand what they create. DALL-E can generate a perfect image of a hand holding a cup. But it has no concept that hands are part of bodies, that humans use them to grasp objects, or that cups contain liquid. It only knows statistical visual patterns. Hands usually have 5 finger-like protrusions. Cups are cylindrical with handles. This creates bizarre failures. The AI learned visual patterns without semantic understanding. It knows hands have finger-like shapes, but not how many or in what arrangement. This is the uncanny valley of AI art, sophisticated enough to fool you initially, flawed enough to unsettle you upon examination. Understanding these limitations is critical for effective use of these tools. So where is this technology heading? Video generation has arrived. Runway, Pika, and OpenAI Sora apply the same diffusion principles across time. Text becomes motion, scenes, narratives. Three-dimensional generation is emerging. Text to 3D systems that output game-ready models, not just flat images. Real-time generation is accelerating. Soon you'll adjust prompts and watch images evolve instantly, sculpting with language in real time. And most profoundly, AI-assisted creativity becoming standard professional practice. Not replacing artists but amplifying their capabilities. Concept artists exploring dozens of variations in minutes instead of days. Designers rapidly prototyping ideas that would have been too time-consuming to manually sketch. Filmmakers visualizing scenes before expensive production. The tool isn't the threat. The question is who controls these tools, who benefits from them, and how we compensate the creators whose work made them possible. Here's what actually happens when you type a prompt into an AI image generator. Your words become mathematics. Mathematics guides controlled chaos through thousands of steps. Chaos resolves into coherent form. Form materializes as pixels on your screen. No painting. No drawing. No consciousness involved. Just diffusion models reversing entropy, steered by language embeddings, trained on humanity's visual heritage. Whether you're using Midjourney's artistic excellence, DALL-E's instruction following, Stable Diffusion's open customization, Firefly's commercial safety, or Leonardo's asset consistency, the underlying process is identical. Noise sculpted into reality by mathematics and pattern recognition. It's not magic. It's not theft. It's not intelligence. It's pattern recognition at unprecedented scale, producing outputs that challenge our definitions of creativity itself. The question isn't whether AI can create art, it demonstrably can. The question is what happens to human creativity when imagination can be manifested instantly, and who gets to decide how this power reshapes art, commerce, and culture. Thanks for watching Think How, When, Where and Why. Subscribe to understand the technologies reshaping our world.